Hello, I welcome you all to this another interesting screencast. The problem reads, determine the constant speed at which the cable at A must be drawn in by the motor in order to hoist or to lift or to raise the load 6 meters in 1.5 seconds. The second problem, we are going to address it, or we are going to solve it in the next video for the sake of time. Both these problems are coming from the Engineering Mechanics and Dynamics 14th edition by RC Hibbeler. So let's start the problem. Let's start solving it. So we have case, this one we'll call it case 1, which is 12-200. This is case 1. So what do we have here? Let's draw our datum. Let's pick our datum to be this point here. This is our datum. Okay. So let's have this point there as our first displacement for A, and then for D there, let's say up to somewhere there, like so. Then for C, maybe let's say somewhere there, like so. Then B, maybe somewhere there, like so. Okay, there we go. Right. Alright, so like we said, this is our datum or reference. This is our datum or reference. So let's call this as position SA. Okay, let's call this position SD. We call this position SC, and we call this position SB. But we do have some other parts of the cables that are constant that I'm just going to label. So we do have this part here. Okay, this part here. Okay, I do have also this part here, and we have this part here, and we have this part here, and we also have this part, and this part. Let's label this. So let's call this as our C1. Okay, let's call this as our C2. You don't have to do this if you don't want to. You know, when we take the first derivative, this will all be zeros. Let's call this C3. Let's call this C4. I'm just showing it in here. Let's call this C5. Let's call this C6. And let's call this C7. Alright. So now let's write down the equations that relates these positions per each cable. Mind you, how many cables do we have? We have one, right? 2, 3. Okay, so we're going to have 3 equations. Because we have 3 independent cables. Alright, so let's do so. So we have the first one, which is SA, okay, plus 2 SD, then plus those constant C1 plus C2 plus C5, right? Then we are just going to say equal to L1. Okay, from here, if you were to take the first derivative of a position so that we have velocity, we're going to have VA plus 2VD. Then these are constants, they are just going to be zeros. Alright, then the second equation in the second cable, what do we have? At C, we have SC plus this part here, okay, which is just SC minus SD. So that's SC minus SD, okay. Then plus the constants, which is just C6 plus C3. Then we are just going to say equal to L2. We take the first derivative with respect to time, then we have VC, 2VC, okay, minus VD, then equal to 0. Then the last equation, but not the least, we have SB, okay, we have SB. So let me just move this a little bit here. and move it maybe somewhere there. Okay, so we have SB outcome plus SB minus SC for this part here. Okay, and then let's add up the constants. We have C7 plus C4 equal to L3. First derivative, we just have 2 VB minus VC and equal to 0 because these are constants. Right, so our VC here, making VC subject formula, we get VC is equal to 2VB. So let's plug in this value. Let's plug it in here in this equation. Okay, so once we plug it in there, what do we have? We have the next equation, which is just going to be equal to 2 by 2 VB is equal to VD, and therefore our VD is just going to be equal to 4 VB. Okay, once we've done this, then we can get this. We go and plug it there. Let's plug it there, VD there, like so. Okay, then once we do that, we're just going to have VA plus 2, then 4 VB is equal to 0, and therefore our VA is just going to be equal to, our VA is equal to minus 8 VB. Okay, VA is equal to minus 8 VB. Alright, so let's indicate directions before we move on. So we said this is our datum, and going down we are going to designate it as positive. Okay, therefore the motor here will be pulling the cable in this direction, which is negative. Okay, and then here this will be hoisted up like so. Okay, which will be, this is positive. The motor will be pulling the cable in the positive direction, and then this one is going to be negative, going up. Okay, so we are calling VB here. We have been told that the load must be hoisted, okay, at this speed, 6 meters in 1.5 seconds. So VB will be equal to minus, okay, this is minus, again minus here because we have assumed, or we have taken our datum as going down being our positive. So minus 6 meters divided by 1.5 seconds. Therefore VB becomes equal to, when we divide this is just a minus 4 meters per second. So our VB is therefore equal to minus 4 meters per second. So when we plug it in there, then we have VA. We are going to have VA equal to minus 8 by minus 4, which gives us VA equal to 32 meters per second, and it's going up. It's going down, sorry. It is going down, which is a positive value. So this is it's going down. This is the constant speed at which the cable is going to be drawn by the motor. Right, I think we are done. We have found the constant speed, which is 32 meters per second. And I hope this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.